Good evening for everyone. Today is a wonderful session that is a biomimetic materials of aerospace lecture by Mr. Ganesh Natarajan. The lecture was organized by Wings of Aero. First of all, I would like to welcome Mr. Ganesh Natarajan and we are thankful to them for accepting this event and also welcome the participants. Uh, I will give the session to Mr. Ganesh Natarajan. Sir, sir.
Uh, a very warm welcome to the eager minds present over here. I am Ganesh Natarajan, a master's student in aeronautical engineering, and today I am going to present a topic on the biomimetic technologies for aerospace applications. So this is going to be an introductory session to this topic. Now, at this point, I would like to thank Wings of Aero for providing me this opportunity to exhibit my insights about biomimetics. And let's get on to the topic. Regarding the former portion of the topic, the biomimetic technologies, the term biomimetic may be most unfamiliar among us. So let me start with a more familiar term, or know biomimetics through a more familiar term. Nature, as we know, nature is a physical world surrounding us, except those made by humans. So particularly in nature we have living and non-living things, and but in specific about the biological life or the living things, we can see that each biological species have some particular feature which was evolved by it. We can see that each biological species is shaped by evolution. So what is this evolution? Why is it so? As we can see that this process is taking on through generations, and this is happening because so that it can abide by the law of Charles Darwin, the natural selection. So what this law talks about is that uh, the survival of the fittest. So the fittest survives. In order to adapt to the environment, each species has to develop some kind of features or adapt to the environment so that it can survive from its predator or find food, etc. Now, this particular features or biological features specific to a species are hereditary, and this can serve as a great deal of inspiration uh, for solving current design challenges. Now, how can we solve engineering problems through this bio-inspired designs? So, the solution to this can be provided by biomimetics. So, recoining the term biomimetics is nothing but learning from nature. So, biomimetics basically what it does is the field of study where it imitates the biological systems or natural features of particular species to solve our engineering problems, which can be more innovative and highly functional. Now, talking about the applications of biomimetics, it has a wide, vast variety of applications, right from architecture. There are bio-inspired architectures, and it can contribute to greener energy, and there are projects related to it. And further into the core portion of this session, the transportation. So, particularly in transportation, I'm going to talk about the aerospace applications in particular, and we had dealt with the former portion of the topic, biomimetics. Now, what is it has got for aerospace industry or aerospace sciences? No, talking about aerospace, for newbies, aerospace is the study of aircrafts and spacecrafts, or the aerospace industry deals with manufacturing, designing, and research upon the aerospace vehicles, that is, the spacecrafts such as rockets and aircrafts such as airplanes and helicopters, etc. Now, aerospace, every domain has some subdivisions or a few divisions in it. Now, aerospace can be broadly classified into these five classes or five divisions. Now, the first portion is aerodynamics. Aerodynamics is the field or the field of study under aerospace which deals with the lift generation and drag. So it is how the airplane flies, and all the principles and laws about it are dependent on aerodynamics. Next, the flight mechanics. Flight mechanics is concerned about controlling an aircraft, and so propulsion. It's basically about the engines, that is the power source which can propel the aircraft so fast so that it can be aerodynamically functional. And structure, of course, for all these purpose, it needs to be in particular form and shape which is provided by the structures, and it needs to be more student to the forces. The fifth portion of aerospace can be classified as space applications. Now, talking about the biomimetic technologies, I would be more than glad to present many biomimetic techniques, but still for this session, I will be constraining it to one biomimetic application for each subdomain. Now, before getting into the biomimetic technologies, aerospace does deal a historical relation with biomimetics. So here we can see some kind of blueprint, or this is actually drawings of Leonardo da Vinci. This is approximately 500 years old, and we can see that the bio inspiration, the level of bio inspirations he had, this replicates a bat's wing. So he was imagining an human-made or flight which can fly. So the human flight was not possible at that age. So this can signify the importance of biomimetics and the historical perspective of it. Now getting into the core portion of biomimetic technologies. So here I'm going to present 5 different technologies and for 5 different subdomains. Starting with shark skin inspired riblets for airplane drag reduction. Now talking about airplane drag reduction. Drag is the retarding force of an aircraft, or we can say that whenever an object moves through a stream of air or fluid, it the fluid provides some kind of resistance to the object in motion. So this can be termed as drag. Now this particular thing is beneficial in terms of efficiency, because the more the drag, the more energy we need to spend. So engineers and researchers are working on technologies which can reduce drag so that they can be airplane can be more fuel efficient or more efficient in a general means. Now, from a biomimetic or bio-inspired perspective, here is a company, Bionic Surface Technologies, which uses the shark skin. So when we observe a shark skin in detail, or when we magnify the shark skin at to micro level, we can see this kind of structure, the dentical structures. So these are nothing but the scales of sharks, and seeing upon this scales of sharks, we can see some longitudinal stripes on it. So this particular portion or feature is known as riblets. So when we see about riblets from a front view, it will be like this in a micro scale. So here, when we apply this riblet technology to aircraft, where instead of a smooth skin, we replace it by riblets, we can reduce drag by 8 to 12%. And this particular feature is not only applicable to airplanes, but also in general to transportation such as ships, cars, and etc. Now, not only decreasing drag by using riblets, the efficiency can also be increased by 4%. And this is not a hypothetical concept, it is a practical concept which is being implemented by this company, Bionic Surface Technologies. So this is an Austria based company. Now next, talking about the common dandelion seeds. Most of us would have seen this kind of seed structure. So what is more inspiring about it? So we can there a researcher in 2018, a team of researchers proved that this kind of design can be used in parachute design purposes. So by using such kind of design of nature inspired dandelion seeds, the efficiency can increase by 4 times, which is nothing but 400% efficiency. So what does it do and what is the inspiration it has got? In some cases, there are reports that dandelion seeds can travel up to 100 miles. Uh, Imagine that it doesn't even have a propulsion system, and you can always see the lightweight structure of it. Uh, as we can see, there are no rigid portions over here. Most of the flight portion is 90% empty. That is, the 90% of the structure is light because it is empty or porous. So why should nature choose such a porous design for parachute? Because here is an inspiring technology or inspiring science behind it. So this particular structure assists the dandelion seeds to travel further by generating a vortex. So consider that there is a flow coming from under the dandelion seeds, such as a case of a dandelion seed falling from a tree or a plant. So in that case, we can see that the flow, when passes through this kind of bristles are nothing but the hairs. forms a vortex kind of structure. So here is a combined vortex, two vortices formed over here. Due to the formation of vortices, there exists a low pressure zone, and comparing to this portion is high pressure. So the natural tendency of fluids or an object is to move towards low pressure zone. So this helps the dandelion seeds to get sucked towards the low portion, so low pressure zone, therefore increasing the height. So this increases the chances of it picking up some gust wind so that it can travel more farther. So this is basically adapted to avoid crowding of seeds. Now, here is another project by Airbus. So this is a biomimetic project where we would have often seen long distance traveling birds such as snow goose, or we call it as geese. So this particular birds follow a pattern or fly in some particular formation. We could observe the V-shaped formation of flight. Uh, we wouldn't have understood the significance before, but researchers have worked upon it and did notice that it has a significant effect on fuel efficiency. So this particular project, the Fellow Fly project, benefits from the V-shaped wake energy retrieval. That is, consider that there is a leader bird. So this the bird which leads is called as a leader bird. Whenever the leader bird flies, it generates wake. So wake is nothing but the disturbance caused due to the motion of an object. So this wake is generated in some particular form. So if any other bird or an object is tended to travel in this wake region, it needs to spend a lot lesser energy than the leader bird. So this is also the phenomenon used by cyclists. So when this kind of technology is applied to aerospace, and here we have an experimental proof by Airbus. So consider there is a plane flying over in some particular coordinate, and when we place, or when another plane follows it within a range of 3 kilometers, it will lie within the wake region. So when this kind of formation is carried out, up to 5 to 10% of fuel can be saved per trip, that is for each trip. So just by following an airplane. So this kind of technology has advantages such as fuel savings or fuel efficiency, and as less amount of energy is required, the CO2 emissions are also less. Now here we getting into one of the most interesting research in field of biomimetics. So naturally, our bodies or natural organisms have a tendency to grow, and this particular feature isn't observed in man-made, human-made objects, because we make an object and it spends its lifetime as it is. But instead, when we look upon nature, the plant starts as a seed and then it further proceeds to a tree or so. But so what if we apply that kind of mechanism into structural design of wings? So here we have a Boeing 777 aircraft. So this is a research carried out and published in a journal, Springer Nature. So if we particularly apply this kind of growth mechanism, or the morphogenesis is nothing but the growth, the science or phenomenon underlying the growth of natural organisms. So what if we code that kind of growth into a designing software so that it could design a structure not only as a rigid structure but also as an adaptable structure, that is, it only provides supports where it is required. So that kind of structure would be more optimal. So here we can see this is the standard design. We have so many elemental members so that the structure can withstand the forces. Now when we apply this kind of code, or when we try to biomimetically design, or in a common words we can say that what if we let the wings grow as if an plant or a branch. So here, when they applied this kind of mechanism to a designing software, they did see that the structure is somewhat varied or morphed in a different structure, and we can see there are lesser number of structural elements or internal structural elements. And the reason is that the structural elements are only distributed on the locations where it is more required, and those are neglected in the regions where they don't. So this kind of technology helps in weight reduction or mass reduction of the design. So this mass reduction, when we reduce this kind of mass, we can say that the manufacturing cost can be reducing. And of course, by reducing this 2 to 5% of the weight, as you know, this kind of commercial airliners weigh about tons and tons. So this kind of bioinspiration can help in saving 40 to 200 tons of fuel for each plane every year. So imagine the cost of that we can save with the increasing petroleum costs these days. So this may be a significant research. And one particular thing, an obstructing point about this is that these structures are complex to manufacture by conventional technologies. So we need some kind of 3D printing technologies, which is costly right now, but it may be getting cheaper later. Now here we get to the last biomimetic inspiration. So this is for space applications. We all would have could have known about rovers, landers, and spacecrafts. So, such as Perspective, which NASA landed recently on Mars. So, everything will be having a 4 wheels or 8 wheels, some kind of structure similar to that of car. So, instead of that, what if we have an unique design inspired from tumbleweed? So, tumbleweed is nothing but the dried weed. Or the branches which circle around as a bunch, and this, due to its lightweight and kind of structure, this can travel or tumble. So tumbling is nothing but moving here for fore and back randomly based on the wind gusts. So this kind of motion is obtained over here. So what if we apply this inspiration to space probes or spacecrafts, such as this kind of probe is used to it was actually designed and submitted to NASA for application in space probes, which can be used to study asteroids. Asteroids are nothing but the near Earth objects, which are smaller planets, which cannot be called as planets due to their lesser mass. So these kind of things, like consider that there can be 4 to 5 kind of probes which can be left over, which can easily travel without wheels, just by flying and moving here and there. Of course, there are few complications such as it depends on wind and so on, but there may be some kind of internal propulsion mechanism too, which isn't discussed further in the detail. So this kind of bio inspirations are existing right now, and there are many projects going on right now all around the world, and we have a lot more to learn from nature. And it of course have has a lot more opportunities to young researchers and already the people involved in research. So it provides a new perspective where people can look into a new approach, that is the biomimetic approach, in their current field of research. So that's it. This was my lecture on the topic biomimetics. Thank you for listening over to me, and I will be more than happy to get few questions if any.
Okay, sir. Thank you. Uh, we also enjoy the session. Um,
Okay.
anyone have a doubts? Okay, sir. Thank you, sir.
Okay, thank you.